xt of omega, we are going to start with. Okay, what is xt of omega? Which is the Fourier transform of xt of t. Okay, this is from the statement. Okay, now we need to write the formula of Fourier transform. So which is from minus infinity to infinity, xt of t e power, yes, so which is minus I omega t dt. Okay, this is the formula. Next step, we are going to replace xt of t as x of t in this integral. Okay, so just replace xt of omega equal to integral from, change the limit from minus t to t, then write this xt of t as x of t, then into e power minus I omega t dt. Okay, am I clear? So first step I want to write this one, then write the formula for that case, then after that replace this xt of t as x of t corresponding to change the limit. Okay, the next thing is what? We are going to take modulus of xt of omega d whole square. Okay, which is nothing but, yes, so we can write this term as xt of omega into xt of minus omega, that is x conjugate. Okay, now we can take xt of omega as the last case, but here we are having two terms, that means we are going to have this t as t1 and t2. Okay, so the first thing is what? Integral from minus t to t x of t1, then e power minus I omega t1, then dt1. Then again integral from minus t to t, then x of, for second case replace t as t2 but the same term. Okay, then replace omega as minus omega, so e power I omega t2, then dt2. Okay, so two terms on the right. Now we are going to combine the integral and exponential. Okay, so in the order we are going. So there are two integral which is from minus t to t, then write x of t1, then x of t2, then e power. You can check in the power which is common, you can take outside. Okay, so okay, the common one is what? Minus I is outside, then the remaining one t1 minus t2, then into omega. So in the power I omega is common, just to take minus also. Okay, then you combine b terms which is dt1 and dt. Okay, the next thing is what? You can check in the reverse. Okay, so this is already done. Now we are going to take the expectation term. So e of modulus of xt of omega d whole square, which is equal to, just bring the expectation inside the integration. So minus t to t, then minus t to t, expectation of x of t1, then x of t2, then into e power minus I t1 minus t2, then into omega dt1 dt. Okay, hereafter we are going to write this expectation of x of t1 and x of t2 as r double x of omega, that is we already know the concept, right? Double integral from minus t to t minus t to t. Now we write this term as what? R double x of the difference between the variables, which is t1 minus t2. Okay, so e power minus I into t1 minus t2 into omega dt1 then dt2. Hereafter we are going to have the substitutions. Okay, now we take t2 as t and t1 minus t2, that is this term as tau. Okay, so finally from this we are going to get t2 as dt, and just replace this t2 as t. So from this we are going to get tau equal to t1 minus t. So from this we are going to find what is t1, which is t plus tau. Okay, then finally find what is dt1, which is t tau. Okay, now we converted t1 and t2 both in terms of t and tau. So we are going to replace it here. So expectation of modulus of xt of omega d whole square equal to, corresponding order, take the limit also. Okay, so the limit for t2, the limit is minus t to t, and the second one is minus t, and t minus t, then r double x of tau, then e power minus I omega tau into this one is what? dt and d tau. Okay, then we need to simplify the terms. So we can separate t term and tau term. So after separating t term, just integrate t. So integration of t is what? T. Then limit from minus t to t. The remaining one is what? Minus t, then t minus t, r double x tau infinity. Okay, finally replace t as infinity here. So we are going to get the term as minus infinity to infinity r double x of tau, then e power minus I omega tau, then d tau. Okay, so this is what? So which is nothing but s double x of omega. Okay, so this is one of the formula for power spectral density. So this way we need to prove the theorem. I think we don't have any clarification. So the close session, yes. Thank you.